All right, let's continue on with our examples. All right, so we've done A. Let's go ahead and do B. All right, so remember, our whole goal is that we're finding the domain of our rational functions. So remember, you can plug in any x value you want as long as the denominator does not equal 0. So for B, our denominator is x squared minus 4. So let me go ahead and write that. And I'm going to set it equal to 0. When I do that, I need to solve for x. So this is quadratic. Remember, you have a bunch of different methods to solve a quadratic function. The easiest method here is to add 4 to both sides and then use the square root method. So that's what I'm going to do. I'm going to add 4. So it's going to give me x squared equals 4. In order to get rid of the second power, I'm going to square root both sides. So that's going to give me x equals plus or minus, don't forget, 2. So that tells me I can plug in anything I want into that function except for positive or negative 2 because it's going to give me a 0 in the denominator. So if I'm following the notation that we used in the previous problem, remember you can write your answer using either set builder or interval notation. So if I want to write this problem in set builder notation, I'm going to write brace x such that x does not equal positive or negative 2, close brace. Okay. If I need to write that same answer but in interval notation, I'm going to write parentheses, negative infinity to negative 2, parentheses, because remember we're not including, union, negative 2 to positive 2, parentheses, union, 2 to infinity. Okay, so notice anytime you're writing these answers in interval notation, the more numbers you need to exclude, the more sets of parentheses you're going to have. So just keep that in mind. Okay, so your answers are going to look like they get longer. Okay. All right, let's move to C. Okay. All right, so C, same thing. They want us to find the domain, but this time for C, our denominator is x squared plus 1. So let me write that. All right, I need to solve for x. So once again, I'm going to get x by itself. I'm going to isolate it. So I'm going to subtract 1 from both sides. Okay, and I need to get rid of the second power, so I'm going to square root both sides. Okay, and here is where I have the issue. Okay, so I have the square root of a negative number. We know anytime we take the square root of a negative number, it's going to give us an imaginary value, which I don't want. So since they're asking me to find the domain is only concerned with the real numbers that create the issues in the denominator, not the imaginary ones. So because there's no real numbers that are going to present an issue for us, the domain for this problem is all real numbers will work. You don't have any issues. All real numbers, okay? So be careful about that. You don't care about the imaginary numbers that are going to give you issues. You only care about the real ones, okay? All right, let's do D. So D says r of x equals x squared minus 1 over x minus 1. So same thing. We need to find the values that are going to make the denominator equal 0. So we have x minus 1 equals 0. I need to solve for x, so I'm going to add 1 to both sides. X equals 1. I solve for x. There's nothing else that I can do there. So that means that I can plug in anything I want into that function as long as x doesn't equal 1. So if I'm following the same examples again, slide this over. In set builder notation, that's brace x such that x does not equal 1. And in interval notation, I'm going to write parentheses, negative infinity to 1, parentheses, union 1 to infinity. Okay, so just keep in mind with all of these problems that we've done, the important thing is that the denominator cannot equal 0 anytime you're finding the domain of a rational function. Okay, so if you keep that in mind, the process for solving them is pretty much the same. You just have to remember that the denominator cannot equal 0. And when you find those values, you exclude those values from the domain.